So Chris, what we'll do is we'll understand what is the oxidation state, and we'll understand oxidation state so that we understand in a redox reaction which element is which party is going oxidation and which party is going reduction. So see, one way in the last lecture what we had done is we had tried to understand what is oxidation and reduction in terms of the gain and loss of oxygen and hydrogen. Yeah. Now in this lecture what we want to understand is redox reaction in terms of the change in the oxidation numbers. Now before we understand what are the change in oxidation number, we will have to understand what are oxidation numbers. And for understanding oxidation numbers, there are few very simple rules. We will do a lot of practice question, don't worry. And once we have understood what is what are oxidation numbers, then when we look at these redox reactions, we'll be able to make out which is going oxidation, which is going reduction using the rules of oxidation number. Chris, is it making sense?
Yes, sir. Yes.
Okay. So let me first go through the rules. We'll do few numericals regarding oxidation state, and then we'll do few numericals regarding the change in oxidation numbers in a redox reaction. So for oxidation state, the rules that are followed are: 1. Each state in a formula has an oxidation state. Oxidation is usually given as Roman numbers 1, 2, 3, 4. Okay, not a problem. When an element is not combined with other elements, its atom is in oxidation state 0. This would be the first important rule that we have to remember. So any element which is in the when it is not combined with any other element, it is considered to be having oxidation state of 0. So for example, if I say Na, or I say oxygen, or I say hydrogen, or I say magnesium, or I say aluminium. Now all these, they are not combined to any other element. So therefore the oxidation state of sodium would be 0, of hydrogen would be 0, magnesium would be 0, aluminium would be 0. Is it making sense, Chris?
Yes, sir.
Okay. Now okay, so this is rule number.
So oxygen will be 0.
Yeah. So for example, let us look at the rule again. When an element is not combined with other element, its atom are in oxidation state 0. So oxygen is not combined with any other element. That is why its oxidation state is 0. So for example, in H2O, oxygen is combined with some other element. Here the oxidation state won't be 0. Have you understood what I've said?
Yes, sir.
Similarly, if you look at hydrogen, here hydrogen oxidation number would be 0. But here in H2O, it won't be 0. Is it making sense?
Yes, sir.
We'll do examples, don't worry. Then, when we look at the rules for other, we'll discuss this in a while, hydrogen in a while. But sodium, calcium, aluminium, chlorine, its their oxidation number are always +1, +2, +3. Chlorine as well as other group 7 nonmetals in the compound without oxygen, their oxidation number is -1. Is it making sense?
Yes, sir.
Usual, see if you look at this word, usual oxidation of oxygen is -2. It can change, but usually it is -2. Is it making sense?
Yes, sir.
Similarly, what you need to remember is that the usual oxidation of hydrogen is 1. But if it is making a metal hydride, what do we mean by metal hydride? So, for example, let us assume that we have a compound like, say, NaH. Now sodium will always have oxidation state of +1, and that is why in case hydrogen is with a metal, its oxidation number would be -1. Is it making sense?
Yes, sir.
Then then there are transition elements. Transition elements are those when they do
The hardest elements.
yeah, when you look at a periodic table, these are called the transition elements. So these transition elements, they have what is called a variable oxidation states. Is it making sense?
Yes, sir.
So you know, the better way of understanding oxidation number is by doing lot of numericals. I'll be sharing this PDF with you. This is one of the best
Yes.
PDFs. This is one of the best PDFs which is available on Google. So very elementary. If you go through these 3-4 pages, you will understand oxidation state. So one is oxidation number of all elements in a neutral molecule must add up to 0. Yeah, makes sense. So for example, what he is saying is that if I have a neutral molecule, let us assume I have H2. Even if I have a ionic compound, say CuSO4, mixture of ionic plus compound, here also the oxidation number of all the atoms, oxidation number of copper plus sulfur plus oxygen will add up to 0. Is it making sense?
Yes, sir.
So this is what we were discussing. The oxidation number of elements in the elemental form is 0. This is what they were saying. So for example, now when you look at the examples, now I think it will start making sense. So for example, if you look at oxygen, if you look at fluorine, if you look at chlorine, if you look at sulfur, if you look at nitrogen, it is not combined to anyone else. That is why if you see the oxidation numbers are 0. Is it making sense?
Yes, sir.
But the oxidation number of any monoatomic ion is the same as its charge. What does this mean? So for example, if I have cobalt +2, chlorine negative, Mn +2, chromium +3, now this would be the oxidation number. Is it making sense?
Yes, sir.
And if I look at something like this, Hg2 +2, then each Hg has an oxidation number of +1. Why? Because I have 2 Hg. So that is why if each of them has +1 oxidation state, the total oxidation state would be +2, which is equal to the charge on the ion. Is it making sense?
Yes, sir.
Okay. So now that is why I was telling you that this PDF is very good for practice. So for example, we look at rule number 2, the fluorine always will have an oxidation number of -1. This is fixed. This will never change. Is it making sense?
Yes, sir.
Now I'll take a few of the examples to illustrate how the calculations are done. So for example, one second. Chris, one second. So if I look at this, then how do I calculate? Now what I know is that the fluorine oxidation number will always be -1. It will never change. So if we look closely at this, what will have to happen is that the charge on this ion will have to be -2. But fluorine would always be -1. So let me assume that oxidation number of sulfur is X. So I will write this as X plus 6 into -1 is equal to -2. Chris, have you understood this?
Yes.
So X would be equal to 4. Is it okay?
Yes, sir.
So that is how this oxidation number of sulfur is calculated. Now the rule number 3 that we have already discussed, for group 1A the oxidation number would be +1. For all group 2A elements it will be +2, and these 3 elements will have an oxidation number of +3. Is it making sense?
Yes, sir.
Let me do another example for you. So for example, if I have to find the oxidation number of phosphorus, now what I know is that the oxidation number of sodium is +1. Let me assume that the oxidation number of phosphorus is X. Then there are 6 atoms of fluorine. Each will have a oxidation number of -1. So this would be 6 into minus 1, and the net would have to be equal to 0, because there is, if you see,
Yes.
this compound has a no net charge, so this would be equal to 0. Therefore x would be equal to 6 minus 1, which is will be equal to 5, and that is why you see oxidation number of phosphorus is 5. Is it making sense?
Yes. Yes.
When we look at hydrogen, the oxidation number is +1 when combined with the non-metals. So hydrogen has a very interesting case. For all, when it is combined with non-metals, its oxidation number is +1, and when it is combined with the metals, then it is -1. So for example, if we let us take example of this NH3. So NH3, I want to have the oxidation number of nitrogen. So because this is a non-metal, so hydrogen will take the oxidation number of +1. So it would be x plus 3 is equal to 0, because there is no net charge on this molecule. Therefore x would be -3. Therefore oxidation number of nitrogen would be -3. Is it making sense?
Yes.
But if I look at, let us assume we look at this NaOH. Now Na will always take oxidation number of +1. Usually oxygen takes oxidation number of -2. Hydrogen, I don't know. Let me call this as x. So +1 -2 plus x is equal to 0, and x would be equal to 1. Do you see this one as the
Yes.
oxidation number of hydrogen?
Yes, sir.
But now one thing that we would have observed is that if I take example of NaOH, Na consists of Na positive and OH negative. Is it making sense?
Yes, sir.
So if this oxygen, hydrogen in this case is combined with this oxygen, because hydrogen in this case is combined with a non-metal, that is why this acceptable value of +1 is being taken. Is it making sense or not?
Yes, that's making sense.
Yeah. So that is why you can take it either way. You can take the value of hydrogen to be +1, and if you take the value of hydrogen to be +1, you start with the assumption that hydrogen is having an oxidation number of +1, and then you take the oxidation number of oxygen as x, and equate this to be -1. X would come to be -2. So either way, this calculation is making sense. Have we understood this? Then, Chris, am I audible?
Yes, sir. Yes, sir. You are audible.
So oxygen, this is what we were discussing, that usually oxygen will have a oxidation number of -2, and the group 5A will have oxidation number of -3, -2 and -1. So basically what is happening is we are starting from +1, +2. We have aluminium and 3 elements were given which were +3. Then finally when we come to the noble gases, of course their oxidation number would be 0. But from this side, halogens -1, this would be -2, and this would be -3. Is it making sense, Chris?
Yes.
These are 7A elements, these are 6A elements, these are 5A elements. This is what they are saying. Chris, are we clear?
Yes, sir.
Okay. Now do me a small favor. We'll try to do few sums, just for practice sake, using these rules. Yeah. Try to solve these questions.
Yes, sir.
The questions which I am marking.
Yes, sir.
Have you understood the rule?
Yes, sir.
Just do these few questions and then we'll come to the redox reactions.
Yes.
Just spend some time on this. Yeah, you can start. Actually, this is what we had done. So you can do these. I will send you this PDF. If you want to practice this further, you can use it. But
Yes.
just do this.
Yes.
They have mentioned the element for which they want the oxidation number. So for example, they want the oxidation number of N, Mn, Ag, Au, Os, Fe, Sau. Try to do it. We'll discuss in a few minutes.
Yes. So I need a periodic table for this.
Yeah. Can you Google periodic table, or you can refer to your textbook,
Yes.
or you can Google periodic table any way you like.
Yes, sir.
So these are the solutions of this PDF. Let us discuss few of them. So HNO3. Now, what I know is for HNO3, what I know is that hydrogen and nitrogen, oxygen, hydrogen is connected to non-metal, so hydrogen would be +1. Nitrogen I am assuming to be X, and oxygen would be -6. -2 into 3 would be -6, and whole, because there is no charge on the entity, so that is why this would be 0, and X would be equal to 5. So my answer is correct. Is any doubt?
No.
Again, if I look at MnO2, this would be X, this would be -4, so no charge per se, that is why Mn is +4. Any doubt?
No, sir.
If I look at Au2O, I'm just skipping it for 5 minutes. I'll come back to this. Just give me 5 minutes. Au2O, then oxygen is -2. This would be 2x. So 2x minus 2 is equal to 0. Therefore, x is +1. Any doubt?
No, sir. No.
Again? Yeah, Chris. Chris, any doubt?
No, sir. No.
Okay, so if I look at the next example, again, if I assume this to be x, so this will be 2x minus 10 is equal to 0. Therefore, x would be 5. In this case also, this would be -2, this would be +2. In this case, hydrogen is combined with a non-metal, so this would be +2, this has to be -2. Any doubt? Chris, any doubt?
Huh?
Any
No,
doubt?
sir.
Yeah. So let me skip this for 2 minutes. SO3. So oxygen is -6, so sulfur would have to be +6. This is chlorine. It is not combined to anybody, so that is why oxidation number is 0. And this is here chlorine would have to be -1. So 2x minus 2 is equal to 0. Therefore, sulfur would be +1. Any doubt?
No, sir.
See, examples like this and this are a bit complicated. I don't want to go into much of detail. If you want, so for example, if you want to look at the case like this. So now the oxidation number, they fundamentally oxidation number are based on the electronegativity. Do you know what is electronegativity, Chris?
No, sir.
Okay, so not an issue. But whenever we do electronegativity, maybe we will discuss this example again. But the answer to this question is understood by looking at the structure of this compound. We haven't done the structure of compounds also, so don't worry much. Whenever we have finished with electronegativity, whenever we have finished with the writing the structure of the compound, we may come back to this, but the answer to the question is +1. We can skip this for a while. Any doubt till here?
No, sir.
Okay, now let us come back to our primary purpose and understand. Let us come back to our primary purpose and try to understand how can we use this oxidation state to find what is being where the oxidation and where the reduction is taking place. Just do me a small favor, just copy these examples.
Yes.
So let us try to understand these with the help of the oxidation states. So here iron is not combined with anybody, sulfur is not combined with anybody, so the oxidation state would be 0 0. Any doubt, Chris?
Yes. No, sir.
Now
No.
when you look at FES, now what we find is that see, sulfur and oxygen, they are in the same group. So if I have to guess the oxidation state of sulfur, it would be -2. If this is -2, then iron would be +2. Any doubt?
No, sir.
Now let us look closely at what has happened. Let us look closely at what has happened. See, iron has gone from 0 to +2. Its oxidation number has increased. Its oxidation number has increased. Therefore, it will undergo oxidation. If we look at sulfur, it has gone from 0 to -2. Its oxidation number has reduced. That is why it has undergone reduction. Any doubt, Chris?
No, sir.
See, we are trying to understand the redox reaction with the help of oxidation numbers. Have you understood what I am trying to tell you?
Yes. Yes.
So FeCl2 plus Cl2 gives FeCl3. I am not balancing the equation. But if we see, I know that chlorine in its uncombined state, when it is not combined to anybody else, it will have an oxidation number of 0. Here it is combined with iron, so it has to take -1, and this would be x minus 2 is equal to 0, therefore x would be +2. Now when I look at FeCl3, again Cl has to take -1, this would be +3. Is it making sense, Chris?
Yes, sir.
Now if I look at iron, it has gone from +2 to +3. Its oxidation number has increased, therefore it has gone oxidation. If I look at chlorine, its oxidation number has gone from 0 to -1. Its oxidation state has decreased, therefore it has gone reduction. Chris, any doubt?
No, sir.
Let us look at the next solid example. So for example, when we look at NH3 plus HCl gives NH4Cl. So here hydrogen is combined with the non-metal, so +1, this would take +3, this is -1, this is +1, this is -1, this is +1, this is +4, -1, 3, so this has to be -3. Chris, is it making sense?
Yes, sir.
Now nitrogen, let us look at what has happened to nitrogen. Nitrogen has decreased the oxidation number, so nitrogen has gone reduction. Let us look at hydrogen. Hydrogen, no change in hydrogen, +1, +1, +1 on both sides. But then what has happened to chlorine? In chlorine, again the oxidation number is remaining the same. Any doubt?
No, sir.
Now, oh, I've made a mistake. 1 second. This would be -3. I'm sorry. This would be -3. So that is why the -3 and -3. I'm sorry. Because no change in oxidation number is happening. No change in oxidation number is happening. Either for hydrogen or for chlorine or for nitrogen. That is why this is not a redox reaction. Any doubt, Chris?
No, sir.
We'll do just 2-3 more examples. We had done this using the oxidation reduction. These questions we had done using the concept of gain and loss of oxygen. Now this time we will try to do that in terms of the change in oxidation number. Try to do the C part, E part and F part. Try to do these parts and tell me
Whether they
what
are.
is yes using oxidation number. Try to do these questions. C,
Sir, do I have to tell they are being oxidized or reduced? Or do
You
I have
have
to tell
to,
they are
yeah, you'll, yes, you'll have to
redox?
tell me, yeah, you'll have to tell me the oxidation numbers of all the elements in the compounds.
Yes.
Have you understood? So the first reaction is CH4 plus oxygen. I'm not writing the balanced equation. Doesn't matter because I'm
Yes.
just focusing on the oxidation number. So when I look at CH4, methane, so this would be hydrogen would be plus 1, carbon would be minus 4, here oxygen is 0, here oxygen is minus 2, this is plus 4, this is plus 1, and this is minus 2. Is it making sense?
Yes, sir. But hydrogen will it be -4 or +4?
See, hydrogen, because oxygen is minus 2,
Yes.
it has to be plus 1. Why? Because plus 2 minus 2 would be 0. Is it making sense?
Yes.
Now, now in this reaction, if I see my carbon remains the same,
Yes, sir.
my hydrogen remains the same, my oxygen has gone from, no, 1 second, yeah, my carbon has gone from, oh, sorry, my carbon has gone from minus 4 to plus 4. So my carbon oxidation number has increased. So that is why my carbon has got oxidation. My oxygen has gone from 0 to 0 to minus 2. Its oxidation number has decreased. That is why it is going reduction. Any doubt, Chris?
No, sir.
So let us look at E now. So again, I am not balancing the equation. Fe plus O2 gives Fe2O3. Again, oxidation states this is 0, this is 0, but here oxygen would be minus 2 and iron, let us assume to be x. So 2x minus 6 is equal to 0, x is equal to plus 3. So this would be plus 3. So my iron has gone from 0 to 3, increase in oxidation state. So this is oxidation.
Oxidation.
0 to minus 2, reduction. Why? Because there is a reduction in the
The
oxidation number.
uh,
Any
yes, sir.
doubt, Chris?
Increase of electrons.
So, in see another way, yes, another way in which you can say this, if you use the definition of oil rig, oxidation is loss of electron. Oxidation is loss of electron. So, if you see this 0 to plus 3, the here loss of electrons is taking place. Reduction is gain of electrons. It is getting negative charge. It is getting electrons. It is accepting electrons. That is why you see from 0 to minus 2. That is why reduction is taking place. Chris, any doubt?
No, sir.
So this concept of oxidation number or oil rig, it is one and the same thing. It is one and the same thing. I like this concept of oxidation number because even in confusing cases, things become very simple when you understand what are oxidation numbers. So let us look at this final example. So here this would be this is minus 2, this is plus 3, this is minus 2, this is plus 2, this is 0, this is minus 2, this is plus 4. And let us look at iron reduction. Why? Because there is a loss of oxidation number. If I look at carbon, it is increasing, so there is a oxidation taking place. Do you see how easier it becomes when you are looking at the reaction in terms of oxidation number? That is
Yes.
what I wanted to cover today. Any doubt, Mr. Chris?
No, sir.
So let us meet on Tuesday.
Yes.
Uh, can you meet on Monday also?
And
Then
yes.
we can take Tuesday off.
Yes.
So,
Monday
but
6:15.
Monday, 1 second, 1 second, 1 second, 1 second. No, let's meet on Tuesday, yaar. Monday again won't be possible. Tuesday, same time, 6. Tuesday we meet at 6, na? Yeah.
Yes, sir.
Yeah. So let's meet at 6. Yeah?
Yes, sir.
Okay.
Bye, sir.
I'm
Thank you.
closing the meeting. Yeah. Yeah.
Yes, sir. Bye, sir.
Okay.